Hi, and welcome. I am Dr. Pam Hurst Della Pietra, President and founder of Children and Screens, Institute of Digital Media and Child Development, and host of our popular Ask the Experts series. Thank you for joining us today for our much anticipated webinar focusing on the complex ways that digital media impact children's development, brain structure, and function. Over the next 90 minutes, our panel of world-renowned interdisciplinary experts will discuss the risks and benefits our children encounter in terms of their attention spans, memory, creativity, ability to learn, and to think deeply and critically as they consume more and more media, as well as how they can adjust their digital media use to ensure optimal cognitive development. The group will kick us off sharing some of their cutting-edge research about screen time and brains, after which they will be happy to address your pressing questions. Just type them into the Q&A box at the bottom of your screen. When you do, please indicate whether or not you'd like to ask your question live on camera, or if you prefer that the moderator read your question. We're recording today's workshop and we'll upload a video to YouTube in the coming days. All registrants will receive a link to our YouTube channel where you'll find videos from our past 37 webinars, which we hope you'll watch as you wait for this video to be posted. Be sure to check out how you can win a chance to select your very own webinar topic between today and Friday, November 19th, when you donate at least $100 to Children and Screens, Institute of Digital Media and Child Development. You will automatically be entered into a raffle to choose one of our 2022 webinar topics. The funds will support the Institute in providing more terrific programming. It is now my pleasure to introduce our moderator. Dr. Martin Polis is Scientific Director and President of the Laureate Institute for Brain Research, where his research focuses on using neuroimaging to develop predictive biomarkers for anxiety and addictive disorders, using computational psychiatry to better quantify the behavioral dysfunctions in individuals with mood, anxiety, and addictive disorders, and developing a research pipeline to translate basic neuroscience discoveries into clinical useful tools. Dr. Polis is a member of the Adolescent Brain Cognitive Development Study, ABCD, which he will speak more about shortly. Welcome, Martin.
Thank you, Pam. Thank you, and thank you everybody for attending today. I hope we're going to have a exciting set of presentations, and I think we'll try to get an invigorated discussion going. So I'm really looking forward to this, and please don't be shy. If you have questions, that's why we're here. We want to answer your questions. So before we get to the speakers, which we have three, two will be live and one will be a recorded speaker, let me just do a little bit of an introduction and show you a little bit of what we've been doing that is related to screen media activity. So I will start sharing my screen. Okay, so let me talk to you a little bit about screen media activity and cognition, and get right into what do we mean actually by the term cognition. It's a very broad term, quite frankly. It involves really multifaceted processes. So the easiest way that you can probably kind of organize it is into sort of three main categories, sort of that is shown on the right hand side in the picture here: the input, the storage, and the control. So let me kind of just walk you through this. What do I mean by input? Well, input is sort of what you perceive, what you're perceiving, the concentration, the attention you have to exert to perceive a particular outside stimulus, the degree to which you are aroused or the degree to you are awake while you're doing the perception. So that's wakefulness. Then you have the operations related to taking what you've taken in and store that in your brain for further retrieval in the future or for other processing, which we'll get to in a moment. But in a storage sense, you have what's called working memory. Working memory is basically your scratch pad memory. It's what, you put a phone number in the olden days when you had to run to your phone and type it in. It's essentially a short-term limited buffer that you're operating on. Then you have your long-term memory, things that happened, quite some time ago that you remember at various times. But then you also have the process of forgetting, because sometimes it's important not to remember something, but to forget something. Forgetting is actually a very important active process as well. So that's part of storage operations. And then finally, you have the control over these various processes, the input and the storage process. So you have, decision making, planning. What sequencing. What are you going to do? If I'm going to the store and I'm going to have to get these types of items, and then I'm going to pick up my son or whatever it is you're doing. And so that's the planning ahead. Then also the flexibility, right? You might see, okay, I'm going to have to take one road. Oh, I see that there's an accident on that road. Now you have to take another road. So you have to kind of plan to do something different. So that's cognitive flexibility. And then you have the issue of impulse control, which has to do with when something occurs to you, do you act on it on impulse, or do you act and deliberate? Think, well, is this the best way of how I should actually act and do things? And I want to emphasize, this is just one way of conceptualize a very complex aspect of, or a very complex process of cognition. But it should give you a sense that cognitive processes is not just one thing; it's many things. It involves many brain areas, and as you can see, there, in terms of the complexities, it shouldn't be too surprising that it develops at different stages in the child's and adolescents and even adults' development. Some of the control processes that we're exerting aren't fully developed until the third decade of your life, so the mid-20s, and so it really spans a number of different processes. We'll hear by some of the folks today really how screen media and social media activity affect these processes. So, of course, part of this is motivated by the fact that we're very worried about changes that are happening in front of our eyes. We are experiencing something that really we haven't experienced before at the with a rapidity that we haven't experienced before. Our kids 5 years ago consumed screen media activity different than they're doing it now, and they will do it different in 5 years from now. So we are faced with the challenge to try to make sense out of what this does to the brain and and how that affects the processes that the brain performs, cognition being one of them. So we, as Pam pointed out, we are part of the ABCD study, the largest studies in young kids ever conducted. It's about 11,000 kids participating over 10 years from age 9, 10 to age 19, 20. And they're basically being invited to come repeatedly during that 10 years. We do brain scans. We get all kinds of cognitive assessments. We're asking symptom questions. We're asking questions about their environment. It's a very comprehensive study in some ways. But at the same time, our screen media activity assessment, at least at the beginning, was relatively limited. It asked about really a short survey about how much TV and movies they're watching, whether they watch videos, whether they play video games, whether they have a text or use the cell phone, computer to chat, whether they're going on social networking sites, and whether they're doing video chatting. So it's very, very simple, straightforward questions where the youth basically gave us information about how much they were doing. Of course, you can imagine at age 9, 10, there's still some limited activity. But as we've learned over the last 3 to 4 years, which is how long the study has been going on, that these activities have been increasing dramatically. One thing that we're also asking is overall, tell us how much screen media activity you're doing. And what we were interested in is, we did one study looking at what are the brain-associated changes, but we were also interested in what might its effect being on something like fluid cognitive functioning. So what is fluid cognitive functioning? Well, fluid cognitive functioning is sort of the capacity to learn, solve problems, and adapt to novel situations, which is vital for a child's success. It's often predictive of how well somebody will do in school, how well somebody will do in life. And again, as I've talked about before, it's part of cognition, but it's really a broad ability of executive function, attention, inhibition, processing, and all those things. And what we were interested from an exploratory approach is the relationship between screen media activity and this fluid cognitive function. What we did, we used kind of some fancy machine learning approaches just to kind of see, can we predict fluid cognitive function from a variety of different variables? And indeed, we can. The predictions are modest, so it's not like we can tell with high precision, but we have some predictive ability that's shown here in this little circle. We predict about 15% of the variance, which is, again, modest. And here are the factors that are influencing that prediction. And one of the things that was what we call a modifying factor is the weekday screen media activity, meaning how much time they spend. And the direction was that more time spent predicted lower fluid cognitive function. And this could be seen here in this particular graph among these other graphs. You can see that on the x-axis, it basically shows how much they're spending time on the screen media, and on the y-axis is the predicted change in fluid cognitive function. So you can see that that as more time is spent, the function overall goes down. So that's one way of quantifying it. And again, this was a first cut at this, and there's many more follow-up studies that we need to do. Moreover, this is an association study. We don't have strong cognitive, strong causal data yet, and we can discuss it maybe at the end, is how we might actually go about doing this. But I think that just to kind of finish up with this particular presentation here is that, in addition to socioeconomic disparity factors, which are also important, that were previously associated with poor cognitive function, other people have reported about this, we identified several novel and modifiable behavioral factors. We looked at participation in extracurricular activities, which are positively associated, screen media activity, which are negatively associated, and also sleep duration. I didn't talk about the other two because they're less germane to the discussion that we're going to have today. But what the point is that, screen media behavior is a modifiable factor. So maybe, in addition to these other factors, by moderating screen media activity, we might afford our kids to have better fluid cognitive function in the future. That's certainly what we're trying to see. Can we provide more evidence in that direction? So that's a short introduction to cognitive function and a little bit of data that we've studied. So I'm going to stop sharing my screen. And I'm going to introduce our first panelist. I'm very excited to have a great group of panelists. So our first participant will be Dr. Mark Potenza. He's a board-certified psychiatrist with subspecialty training in addiction psychiatry. Currently, he's the professor of psychiatry, child study, and neuroscience at the Yale University School of Medicine, where he's the director of the Division on Addictions Research. The Problem Gambling Clinic, the Clinic of Excellence in Gambling Research, the Women and Addictive Disorders Core of Women's Health Research at Yale, and the Yale Research Program on Impulsivity and Impulse Control Disorders. So you can see he has a very, very broad but also deep expertise in the kinds of topics that we're discussing today. So I'm very excited to have Mark take over. So Mark, if you want to share your screen, we can get started with your presentation.
Thank you very much for the kind introduction. And so I'll be following up on Dr. Paulus's talk on screen media activity and cognition. I have a series of disclosures with respect to gambling, gaming, legal, and pharmaceutical entities. And I thought I would pick up on the topic of the complexity of cognition by putting it also into a developmental framework and the multiple factors that may influence cognition during development. And Dr. Paulus touched upon a number of these, including sleep, but also mental health, stress, as well as individual differences that may reflect resiliency or vulnerability factors, such as attention deficit hyperactivity disorder. And I think these are important considerations if we're going to think about brain behavior relationships with respect to screen media activity and cognition. So one study in which we were involved was conducted in South Korea, and it looked at transitions in problematic internet use in 650 middle school aged boys. This was conducted over a 1-year period where at baseline, about 15% of the group had at-risk or problematic use of the internet, and about 85% were in the low-risk group. And then at the 1-year follow-up, there were transitions. So about 15% of those who had high-risk behavior at the beginning persisted with high-risk behavior, and 85% remitted, whereas in the low-risk group, about 12% had emerging at-risk or problematic internet use, whereas the remainder was demonstrated persisting low risk. And so we were interested in the factors that were related to these transitions. And of a multitude of factors that were investigated, 3 were related to these transitions. So fewer days free of internet gaming, as well as cognitive aspects of ADHD. And by cognitive aspects, these are planning and organizing capacities or abilities. These were linked to the emergence of at-risk or high-risk problematic use of the internet, whereas fewer hyperkinetic symptoms, so the difficulties with sitting still, for example, was related to the remittance. So if there were fewer symptoms of hyperkinetic ADHD, this was linked to remittance over the course of a year. And as we know, there's a wide range of behaviors that can be conducted on the internet, gaming being one of many. And that's been a focus of some of our work, as well as the focus of the Diagnostic and Statistical Manual, as well as the International Classification of Diseases. And both of these include criteria for DSM-5 internet gaming disorder and for ICD-11 gaming disorder. The criteria differ, but they are both getting at problems with internet gaming or gaming in general. So we've been involved in a number of different studies looking at largely young adults and males more than females in most cases. But we've also undertaken meta-analytic studies to try to get at robust correlations or findings. And these findings shown here are from a meta-analysis. So across hundreds of individuals, brain imaging studies that found that individuals with internet gaming disorder had lower brain matter volumes in regions like the anterior cingulate cortex, which has been implicated in self-control and cognitive control, and the ventral medial prefrontal cortex that has been implicated in a large number of processes, including decision-making, emotional regulation, motivational drive. We've also, with colleagues in China, been involved in brain imaging studies, in this case, looking at functional connectivity within an executive control network in individuals with and without internet gaming disorder. And what we found was that the individuals with showed less functional connectivity in this network, and that in the sample overall, the less functional connectivity was linked to poorer cognitive control assessed out of the scanner. And then in a separate meta-analysis conducted by Marcia Luchin and colleagues, individuals with addictive disorders, including substance use disorder and gambling disorder, show a blunted activation of the ventral striatum during reward processing, particularly the anticipatory phase of monetary reward processing. And some work in which we've been involved, again in China, has shown something similar in individuals with internet gaming disorder. And how people process rewards is important for learning. And I believe that this will be a topic later in the webinar. So we've been fortunate to assemble a group of interdisciplinary researchers and clinicians to do secondary data analysis of the ABCD data that we heard about from Dr. Paulus, and glad to have Dr. Paulus, among others, involved in these efforts, as well as Yihang Qiao, who is multiple principal investigator on several grants, including a Children in Screens pilot grant that led to a National Institutes of Mental Health grant, so that we can understand better brain behavior relationships with screen media activity. And we've been using an approach called a joint and independent variance explained to look at brain structural covariation patterns. And in a prior publication, we identified a joint structural covariation pattern that was linked to initiation of alcohol use prior to adulthood. In the ABCD study, we heard from Dr. Paulus that this is a large study of over 11,000 youth, and there are brain imaging assessments every 2 years and behavioral assessments every year. And a study that Dr. Paulus led initially linked brain structural factors to screen media activity. 4 different factors accounted for 37% of the variance, including a factor linking cortical thinning to screen media usage. And these data were cross-sectional in nature. And given the longitudinal aspect of ABCD, we were interested in looking at the longitudinal relationships. So in some of our initial analyses, hot off the presses as it were, we identified 3 joint components linking baseline screen media activity at age 9 to 10 to different scores from ages 9 to 10 to 11 to 12 years in cortical thickness, surface area, and subcortical gray matter volume. And these covariation patterns involving these cortical and largely subcortical brain regions were highly reproducible, with Pearson's correlations ranging from 0.82 to 0.91. We didn't find strong relationships with cognitive or externalizing or internalizing scores, but we did find a gender-related difference in one component. And this component included the brainstem, largely subcortical brain regions, including the hippocampus and thalamus, as well as the frontal pole and diencephalon. And what we saw was that there was this difference between boys and girls. The girls are shown in red, the boys in black. And we can see that this separation, particularly for the high total screen time. And when we looked at the types of screen media activity, this appears to be linked to gaming behaviors among the boys. So we've also been involved in a COST initiative, a European Cooperation in Science and Technology, that Naomi Feinberg has been leading out of the UK. And I thought it would be important to discuss one resource, and there are multiple resources, to think about how we might address problematic use of the internet. And this e-booklet is available for free. One can download it if one goes to the website at the bottom of the slide. In this e-booklet covers multiple types of problematic use of the internet, which I think is very important because different behaviors in which people engage on the internet may have different effects on cognition and development. The booklet provides information on the course of problematic use of the internet and co-occurring disorders, covers assessment and intervention information, and provides practical tips, including tips for parents. So some of those tips are to consider age-appropriate content, to gradually introduce the internet in an age-appropriate fashion, and have age-related durations of internet use, to balance screen time and physical activity, not permitting screen time 1 hour before bedtime to ensure sufficient sleep time, and to have screen-free meal times. It's also recommended to turn off digital devices when not in use, and in particular to avoid device use for emotional regulation, as this can then lead into problematic behaviors. To create tech-free zones, to balance screen activity with non-screen hobbies, to have clear and consistent rules that both parents and children follow appropriately, to play video games with others and not in a solitary fashion if one is going to play video games, and to be mindful of the time that that one plays video games, and to have regular conversations about online activities. Furthermore, it's important to warn children about online dangers and encourage that children ask for help when cyberbullied. To teach online ethics, manners, and safe behaviors, be aware of one's own technology use behaviors, be aware of notifications, for example, when muted, to make phones distant when studying, and to be mindful of parental influences on child behavior, because parents remain a very important influence on children's behavior throughout development, even though at times it may not always feel that way. So in conclusion, there's still a lot that we don't know regarding screen media activity and cognition, particularly given the rapidly changing digital environment. However, the ABCD study in particular, and other studies as well, offer unique opportunities to understand brain behavior relationships related longitudinally to screen media activity in youth. As I mentioned, considering types and patterns of screen media activity will be important in this process, particularly for example, social media activity, but also pornography use. These are behaviors in which children and adolescents engage in frequently. And resources such as the COST Initiative e-booklet, as well as guidelines from organizations like the World Health Organization or the American Academy of Pediatrics exist and likely will be refined over time as more information is obtained and gets translated into improved prevention and public health efforts. So I'd like to thank a number of collaborators and funding organizations, and thank you for your attention.
Great, Mark. That was fantastic. Really, some pretty impressive body of work. One question that came up from the audience, and maybe you can respond now, and we can have more detailed discussions later on, is whether kids who have been diagnosed with ADHD, whether the brains of these kids might respond differently to screen media engagement and screen media activity.
I think that's a wonderful question, and I think it's going to be important for us to do those sorts of studies directly to have more information on that. What we do know is that different features, as I mentioned, appear in early studies to be linked to transitions in certain forms of problematic internet use, but we do need to understand brain behavior relationships better, and maybe through resources like the ABCD study that will be possible over time.
Great. Thank you, Mark, and thank you for the presentation. We're going to have a more comprehensive discussion, hopefully, at the end. Next, I will introduce a video for our next participant by Dr. Naomi S. Barron. She's Professor Emerita of the Linguistics in at the American University in Washington, D.C. She's a former Guggenheim Fellow and a Fulbright Fellow and a visiting scholar at the Stanford Center for Advanced Studies in the Behavioral Sciences. For the past 30 years, she's been studying the effects of technology on language, including the ways we speak, read, write, and think. So very much looking forward to that video, and afterwards we'll have a bit more discussion.
Hi, I'm Naomi Barron, and I'm sorry I'm not joining you synchronously today, but at least I'd like to share with you my thoughts and my research on your brain on reading. We'll be talking briefly about screens, conversation, multitasking, and learning. That may sound like quite a mouthful, but they really do all go together. So let's think about reading in particular and your brain, but first focusing on the brain. We know that the human brain is what's known as plastic. That is, it can change over time. It's not just the developing brain in children, it's also as we get older. But we're going to focus today on the children issue. A second thing we know is that our brains were not neurologically designed for reading. No surprise, because literacy and writing more generally have only been with us for, depending on how you count, about 4,000 to 5,000 years. What happens, though, is that as people learn to read, and this is each and every one of us, our brain changes. We know the brains of people who are non-literate as adults are different from the brains of people who are literate. If you're interested in more information on the developing brain regarding reading, I recommend work of Stanislaw Dehaene, Reading in the Brain, as well as Marianne Wolf, her book, Proust and the Squid. Let's focus now on the development of the reading brain in children. And here I'll cite some work of John Hutton at Cincinnati Hospital and some of his colleagues that shows some really interesting correlations. They're not proof, but they're correlations between kinds of activity and what's happening in the parts of the brain that are relevant for learning to read. So in one study done with preschool kids, Hutton and his colleagues was able to show that children who were exposed to a lot of screen use had lower, and I'll quote, lower microstructural integrity of the brain white matter tracts. And what that means is those are areas of the brain that are necessary for developing language and the skills that become important in literacy. With that same cohort of pre-K kids, Hutton and his colleagues found that if you looked at the environment in the home, that is, where there are things that supported the development of literacy, such as access to books and shared reading with kids. When you had less access to books and less shared reading with kids, there was that same lack of development of these tracts in the brain that are useful and necessary for language development. Finally, there was a third study, this time with 8 to 12-year-olds, comparing how much the kids were using screens as opposed to reading. And there was a correlation between high screen use and low book reading, because they often go together. The correlation between those and lower connectivity, again, neurologically in the brain, between the visual word area, form area, and language. Again, things that are necessary for language in general and reading in particular. So that's sort of scary, because it suggests that, at least by correlation, there are some real relationships between how much we use screens and what happens to the reading brain as kids are developing. Let's look now at reading and correlations with toddlers and preschoolers. And here we're going to focus not on the brain per se, but on the kinds of behaviors we engage in. We know there are lots of debates over whether it's good or bad to use ebooks or digital apps versus print with young kids. And by young, I'm talking about toddlers and preschoolers. Over the last number of years, there's been a lot of focus of the discussion on, is it that the kids are focusing on the device rather than the content of stories, which is generally correlated with lower comprehension scores by using ebooks and apps. So is it the problem that they're focusing on the device and not thinking about the story? Another issue is many of the ebooks that are out there and the apps that are out there are full of bells and whistles that have nothing to do with the story. And those kinds of books, electronic books, don't tend to foster comprehension of what is being read. Part of the problem is there aren't many well-designed ebooks and apps out there. There's some, but not a whole lot. But now let's turn to what really matters even more than the digital versus the screen versus the print issue. And that is the kind of conversation that's going on between the caregiver, typically an adult, more typically parents, and the child. There's a term used in the reading community called dialogic reading, which basically means when you're reading to younger kids, and that's toddlers and preschoolers and probably primary school kids, it's important not just to read the words on the page, but to talk about what's happening, to relate what's happening to experiences that your child has. We also know that the kinds of questions that you ask, the kinds of things you say, but particularly when it's asking questions, matter. So-called WH questions, that's the who, where, what, why, how, when, but particularly the why and the how questions are really important to ask about what's happening in the book and how that relates to what else has happened in the child's life. Because the kind of answers that you're requesting from a child are more than one word, and it's not a yes, no. You know, is that a cow? Yes. Well, that's nice, but it doesn't get you to say, why is the cow making noises? Why is the cow saying moo? Because, and that stimulates more language development. This kind of dialogic reading can be done with print and digital, but so far it seems to be easier to do with print because print is a more familiar medium for us. That doesn't mean you can't do it, it means you have to work harder. But now let me turn to older kids. And this is research that I've been doing with a number of my colleagues, particularly looking at the question of how users of various ages, so we've been looking at middle and high school kids, I've looked at university students, how they read in print versus how they read digitally. And today what I'd like to focus on is two specific questions. How easy it is to concentrate when reading in print versus reading digitally, and how often you're likely to be multitasking when reading in print and reading digitally. So what I'll share with you are data that are literally hot off the presses. They're collected from middle, and then we're also working on high school students at the International School of Amsterdam. There are more than 400 we've gathered data on. These were gathered within the last 3 weeks, along with my co-investigators Anna Mangan, Kim Theo Dickerson, and Frank Hockenolder. So these two questions that I want to talk about. How easy is it to concentrate when you're reading in print or on a computer? We had a 5-point Likert scale, easy on one end on the left-hand side and difficult on the other. How often do you multitask when you're reading in print or on a digital screen? Again, a 5-point scale. And it's important to know that the statistics I'll be reporting on are never multitask as opposed to frequently at the other end of the scale. So what did we find? Look at the concentration statistics. This is again from 400 kids. Is it easy to concentrate when you're reading in print? 65% of them said, yeah, it's either really easy or pretty easy to concentrate when I'm reading in print. But when I'm reading on a computer, less than half said it was easy to concentrate. 32% said, yeah, it's easy to concentrate when reading on a computer. Now let's look over at multitasking. Do you never or seldom multitask when you're reading in print? A little more than 3/4 said, I don't multitask when I'm reading in print. But when I'm reading on a digital screen, only 31% said, no, I'm not a multitasker when I'm reading on a screen. So just do the simple math and do the logical connections. If you're multitasking when you're reading, particularly reading when you're trying to learn something, the students themselves are saying, I don't concentrate as well. And you know what? If I'm looking to concentrate, I do it in print better, and I don't multitask. It seems so logical, but we need to draw these connections together. There's one other point I want to make about reading. The kind of reading that students are doing and kids do matters. One of the things that matters is how long the work is that's being read. There's research that shows, and this is with 7 to 16-year-olds, that if you're doing frequent leisure reading, especially of book-length works, school-based comprehension scores are higher. And we know that an awful lot of the reading that we're assigning to kids, and that also goes for university students, is shorter. It's not book-length works. Another correlation has been called the fiction effect. And this was a study of 15-year-olds, and the 15-year-olds who read fiction, and typically that turns out to be book-length works. There aren't a lot of short stories being read. They had higher reading scores on an international test called the PISA than the students who didn't read fiction. So what does all this mean? How do we put this together? I have some suggestions for parents and educators to sum up really what we've been talking about. The first point, remember that children's brains are still developing through adolescence. They're not done then, but that's the group we're talking about now. And that both the kind of media you use, whether it's print or screens, as well as the kind of conversation that's going on, along with how much reading you're doing with kids, how many books there are in the house, that matters a lot for language development, including reading development. In thinking particularly about toddlers and preschoolers, it's important to remember that talking while you're reading about things other than in the book is important. It can be done with books, it can be done without books. You need to talk with children regardless. But if we're talking about books, it can be done with print or digital books, but with print, it tends to be a little easier. And finally, with school-age children, particularly middle school and high school, for which I have real data, model reading, the reading that you do without multitasking. If you're multitasking when you're reading, don't be surprised if your kids think that's a fine thing to do. And similarly, model in your own reading longer works, including fiction. It will pay off, both for you and for your children. Thank you so very much.
Excellent. Thank you, Naomi, for doing this video for us. This is a very, very impressive work. Just to follow up on, there was a bit of a follow-up question, and actually that raises a good point we should be discussing later on. The issue was that when we reported on screen media activity through ABCD, was this a child report or adult report? And in fact, what we used was child report, but we also have the adult report. And the interesting element of this is we did correlations between the child and the adult report. And it shouldn't be too surprising, but it is surprising that the correlations between what the kids report, how much screen media activity they're doing, and what the adults, meaning the caregivers, are saying that they're doing is relatively low, meaning that there probably is a lot of a mismatch between what the parents think the kids are doing and what the kids are really doing. So, let's go to the next presentation, and I'm very excited to have Dr. Jason Chang. He's an associate professor in the Department of Psychology, Cognition, and Neuroscience at Temple University, and his current research in his lab investigates how development and training of working memory and cognitive control impacts the landscape of one's cognitive abilities, including executive functioning, learning, problem solving, and decision making. All those aspects of cognition that I kind of outlined in the beginning. So I'm very excited to have Jason present, and I'll give the floor to him.
Okay, good afternoon, everybody. Thank you, Martin, for the introduction. So what I'm going to do today is I'm going to try to extend some of the arguments that you've heard already presented by our earlier presenters. And I'm going to take us a little bit farther along in development, take us into late adolescence and some of the behaviors that begin to emerge there. Where I want to begin, though, is with some of the sorts of things you might hear in conversations with other parents, maybe you've heard on the news media, out in society. Kids' screen time habits are bad for the development of attention. Kids have short attention spans today, and their executive functioning skills seem to be diminished. That's the kind of thing you might hear. Here's something else you might hear. Technology use disrupts how kids process rewards. Kids are impatient. Kids today, they always expect instant gratification. So as scientists, these are the kinds of questions that we begin to ask. Are these things true? And as listeners today, as members of society, you should always be asking, are these kinds of things that we hear out and about actually supported by evidence? So I'm going to refer to the constellation of psychological skills on the left here as executive control. It relates very closely to the fluid control or fluid cognition that Dr. Paulus was mentioning. We've also heard it referred to as executive functioning in the presentations today. The types of processes that are involved in the comment on the right, I'm going to call reward drive. How reactive somebody is, how sensitive somebody is to the rewards that are present in their environment. And again, the question we're asking is, are these sorts of claims supported? So I'm going to just spend a few minutes weaving a little bit of a narrative in a very compressed and very oversimplified form. I'm going to extend some of the argument to new evidence from other media forms than what I think we've heard about already. And I'm going to first set up the belief that these things are supported. I'm going to show you some of the evidence that leads to these sorts of claims. But as I'm making these sorts of statements about the existing evidence, I want all of you as listeners to put on your skeptic's hat. That is, I want you to think about how these types of data might be real, that we might observe them in the laboratory and in the work that we do in ecological settings, but they might not actually support the conclusions that emerge from the sorts of comments you see in the comment bubbles on this slide. So let's start with executive control. Is it true that more screen time, increased involvement with digital media are associated with an impairment or with weaker executive control, executive functioning? And so I'm going to just, again, walk you through some very simple evidence. There's quite a number of studies. You heard about a few of them from Dr. Potenza, looking at internet gaming and internet addiction. And indeed, these studies en masse seem to show that those individuals who are who spend more time internet gaming, they also exhibit weaker response inhibition, less ability to control their impulses. We find something very similar when we in my lab have been studying increased or excessive smartphone usage. And so the finding is that those individuals who spend a lot of time on their phones, largely engaging with social media applications, well, they perform less well on cognitive measures of flexibility, which was, as Dr. Paulus presented to you, part of this measure of control. And it's the inability to switch back and forth between one task state and another one, to kind of be able to think in different ways in different moments. There's another kind of behavior that's become of great interest in research, there are emerging studies on this. It's called media multitasking. And in this behavior, you're not just engaging with one form of technology or digital media, but you're actually engaging with multiple forms of technology simultaneously. So I think a pretty typical example that you might see in teens is that they're streaming video on one device, but at the same time, they're holding their phones in their hands and they're scrolling through social media. And they're trying to do these two things at the same time. They're media multitasking. And one of the interesting findings from those individuals who tend to be heavy media multitaskers is that they tend to show weaker ability to sustain and control and focus attention. And they show diminished performance on measures of working memory. And just to show you that I'm not just making these statements, I want to show you some actual data. This is from a study by Kane and colleagues. And just to orient you here, what you can see is that those individuals who are heavier on their report of media multitasking using different forms of technology simultaneously, they perform less well on a measure of working memory. It's called the NBAC working memory task. It measures continuous performance, so it's your ability to keep performing this task over time, which is also sometimes used as a measure of sustained attention. So when you put these things together and then you look at how these different media forms affect what's happening in the brain, and again, you've seen some hints of these data already presented to you, what we find is that across media forms, when we look at the brain's structure and its function, we find differences in those who tend to be heavier users who spend more time involved with these digital media forms, they also show both structural and functional differences in parts of the brain that we know to be important for executive control. Dr. Potenza highlighted some of the midline regions of the brain. I'll just highlight one of the outlying areas of the brain, the dorsolateral prefrontal cortex, a region many of you have probably heard is essential for cognitive control, executive control, goal-directed behavior. So you could look at these data and say, yeah, it looks like it's true. Screen media is associated with weaker executive control. Let's turn to the opposite side. Is it true that there's a relationship between screen time and digital media and one's ability to process rewards that are in their environment, their sensitivity, their reactions to, their pursuit of those rewards? Well, again, let's look at some of the findings. So there's a number of studies that have looked at social media behaviors, and one of the interesting and I think quite robust findings is that individuals who spend more time on social media also tend to show increased reward sensitivity. They react more to being given rewards, and they anticipate those rewards with a stronger internal sense. What about internet gaming? There are, again, a number of studies here. And across a number of these studies, we find that novelty seeking, thrill seeking, sensation seeking tends to be high among individuals who spend more time internet gaming. In our own work, again, we've focused more on smartphone behaviors. And what we observe is that those individuals who spend more time on their smartphones, well, they really do look like they prefer more immediate rewards. They'd rather take something smaller and less valuable now than hold out and wait for something more valuable later. And again, here are what those data look like. So I'm just showing you increased smartphone use tends to go with a stronger tendency to want instant gratification. And once again, you might say, oh, I'm sorry. And so if we look in the brain, again, across all of these media forms, the data are highly consistent with this focus on reward drive, reward processing, because among the regions of the brain that look like they're affected both structurally and functionally by increased use of digital media forms are the brain regions that we most strongly associate with the ability to process and anticipate rewards in your environment. So once again, it looks like we're affirming the claim here. And if this state of affairs is accurate, that is, if screen time and digital media involvement is associated with weak executive control and increased reward drive, then here's a way of describing the situation. Executive control has been likened to your brain's ability to put on the brakes, to stop, think, and deliberate. And in these individuals who spend more time in front of digital media, it looks as though they have a diminished control to brake, a weakened braking system. On the other side, the reward system has been likened to having an accelerator with the foot way down on the pedal. You can't control the accelerator, just go, go, go. And this state of affairs, a weak braking system and a particularly heavy foot on the accelerator, is precisely the kinds of conditions that we've been studying for years that are associated with teen, adolescent risk behavior. And this leads to, I think, an important question. Is there a link not just between screen behavior, executive control, and reward processing, but between screen behavior and the kinds of risks that kids and teens are taking? And the answer, if you look across a number of studies, is yes. There is a relationship here. It's true for substance involvement. It's true for involvement in reckless driving behaviors and the likelihood of being involved in both serious and non-serious accidents. It's true for involvement in crime, both violent and nonviolent. That is, those individuals who seem to spend more time in front of the screen also tend to show larger engagement, more engagement in these kinds of important real-world risk behaviors. And again, just to show you, I'm not just saying this, here's some data from my own lab where we looked at digital media use measured across a number of different ways of assessing digital media involvement, and then also self-reported risk-taking within the last 6 months, including these categories of risk behavior. And what you see is a positive correlational relationship. More risk-taking is associated with larger and more involved digital media use behavior. Okay, so given this information, you might try a similar sort of quote to the ones I had in the first slide. Too much digital media exposure is making teens more risky. And that's very tempting to conclude that that's a supported claim here. And what do you do as a parent if that's the observation that you're making. What are the kinds of tips that you often hear? They're not the tips we've given here today, if you look very closely, but the sort of advice you tend to get, and maybe your intuition as a parent or caregiver, is what we need to do is cut down on screen time and digital media involvement, right? Remove social media, get them to spend a little bit less time in front of the screen, and hope that that will diminish their involvement in these risk behaviors. But now I want to present a paradox to you, because over the last decade, we know that screen involvement has gone way up. Many, many more hours per day being spent by our kids in front of their screens. But while digital media use has been going way up, involvement in risky activities has been going down. And this is true for all of the kinds of behaviors that I described. Substance involvement, down. Car accidents among teen drivers, way down. Involvement in crime, going down. They're spending more time in front of the screen, and they're not engaging in more risk behavior, they're engaging in less risk behavior. Well, that raises some interesting questions about causality, about the nature of this relationship. And here's where I want you to pull out your skeptic hat and to ask yourself, is it possible that we have cause and effect going in the wrong direction, that we've been misunderstanding which is the cause and which is the outcome? The way I originally presented it, it's the screen behavior is diminishing control, is increasing reward drive, and as a result, increasing risk-taking. But maybe it goes in the opposite direction. Maybe it's being riskier, having a stronger tendency to want to find ways to exhibit your exploration, to sensation seek. Maybe it's already having a weakened executive control or a stronger reward drive that leads us to the screen. In other words, maybe we have the arrows in the reverse direction. And here's where our strategy for how to address the problem is really important, because if our strategy is to take away the screens, to remove them from our children's lives, then it opens the door again to their involvement in these highly consequential real world risk behaviors that we have seen been going down over the last decade. So I'm going to leave you with two basic conclusions. Yes, there really is a relationship between executive and attentional control, reward drive, and risk-taking, and individuals' involvement in screen behaviors, sitting in front of the screen in whatever form that means, and we can get into the details there. But we should be very cautious in drawing causal inferences from the kinds of data that dominate our fields. And the strategies that we're going to adopt as parents, as caregivers, as teachers, as policymakers need to take into consideration the possibility that the sort of data we have doesn't actually support those causal inferences. Thank you.
Outstanding, Jason. That was quite some interesting twist at the very end. So, and I think a very important one, and I'm sure this will come up in the discussion. Let me just pick up one question that came out of the audience, which is, you make the association between cognition and screen media behavior. I'm wondering, one of the questions that came up is can you actually modify a kid's attention span, say? Is that something that would actually then change potentially if we go the other direction, screen media behavior? So any thoughts on the modification, the modifiability of these cognitive functions?
Yeah, so I think my very short answer is yes, we can certainly modify these executive control abilities, one's attention. And there's, again, a little bit of a paradox, because one of the strategies that looks like it might be fruitful is to actually stick kids in front of the screen again. That is to get them to actually play video games that train up attention, or to engage in computerized training tasks that are designed to increase executive functioning. And although there is some controversy over whether these things work, there's a very large scientific literature supporting the claim that certain kinds of video game play, certain kinds of computerized screen-based activities actually enhance attention control and executive functioning more broadly. Now, if you want to get your kids off the screen, and I certainly understand the impetus for doing that, there are other approaches to improving executive control: exercise, meditation, involvement in structured disciplined activities have all been shown as examples of ways to improve attention span, increase executive control. So I think we can do it. I think we know it's a modifiable feature of a child's brain. And I would say there are a number of different avenues being pursued to try to really narrow down the precise approach to making that work.
Excellent. Thank you, Jason. So, we heard some really exciting presentations, and I want to again thank everybody for making these preparations. Before we get to the general discussion, Mark, you've been sitting here and listening in on some of the presentations. Any thoughts that you have to the presentation you've just heard, and any comments you would like to make?
Yeah, I think that the cautionary note about this being a changing environment where we don't have as much longitudinal data to look at potential cause and effect is important to keep in mind. And it will be important for us to gather more data in what has been a rapidly changing digital technology environment. That being said, parents have children who are growing up, and clinicians are seeing people with problems in these areas. So it's important for us to simultaneously do the best that we can in those arenas with the information that we have.
Yeah, I can only 100% agree with your assessment, and I'm really actually excited that Jason brought this reverse pattern in. Mark, as you know, we wrote this piece that we just published in Psychiatric Times about screen media activity and the consequences. And one of the key problems, and just kind of want to put that out there so that people understand why we're struggling so much with this causal association. To make causal inferences, meaning that something is due to because of something else. We have very limited ways in our experimental armamentarium to actually probe and prove that question. And the classic tool that we would use, of course, is we would take a bunch of kids and we would say to one group of kids, oh, you're going to get as much screen activity as you'd like. And the other group would say, you don't get any. And then we would basically see, okay, so what happens? We basically would follow them up and we would say at the end, okay, the ones that got the screen activity and the ones that didn't, in what ways did they differ? Now, you're all sitting out there can obviously believe that we can't do that study. It's just not doable for ethical reasons, for a number of reasons, practical reasons. So we are inherently limited as to what causal conclusions we can draw. Now, there are some sophisticated tools and methods that one can bring to bear with longitudinal data to get closer to causation. And then those are some of the tools that we'll be using, but you need longitudinal data for this. And that's the other element of it. You've seen a lot of data presentations today that are survey-based, that are cross-sectional. They're useful, but again, they provide limited evidence. And so it is so important that we have these large studies, these longitudinal studies that will help us to better understand this. And so maybe let's get into a general discussion. Given where we are at this point in time, maybe bring it back to Jason. What would be your suggestion to the audience? How should they really take this in? Take the relationship in between cognition, screen media activity, risky behavior, and how should they deal with a situation when risky behaviors emerge? Is it the fault of the screen media? How do we go about evaluating that, even in a specific case?
Yeah, Martin, those are wonderful questions. And let me actually just go back for a second. I'll try to come back to answer this question, but I wanted to put together some of your comments and then what Dr. Potenza had said, which is to say, even if we designed the perfect randomized control study and we could observe over a longitudinal period, those individuals assigned into one group and another, and we could really convincingly show that there's a causal relationship between some form of digital media involvement and the specific cognitive outcomes of interest. One of the things Dr. Potenza said, and I think is really essential, is that we're in a really dynamic digital landscape, right? And we could do that study. We could spend 10 years trying to make the perfect study of how much screen involvement affects a certain outcome, and we'd get an answer. But in the meantime, the digital milieu, the things that we experience in our digital world is changing. The functions and its functionality, what purpose it has for us as individuals is changing. And so we get an answer that's a snapshot in time that may not actually be meaningful as we go forward. So I feel like that's important for us to acknowledge that even the perfect design might leave a lot of open questions. Okay, now to what you've asked me. I think there's a sense of frustration with waiting on science. Science moves very slowly while the world is changing around us. And parents, again, caretakers, policymakers, need to come up with approaches to help intervene. I think all of the tips that were up on the screen with Dr. Potenza, with Dr. Barron, they're great pieces of advice. They're common sense and they make sense. With respect to risk behavior, again, common sense tends to rule the day. Parents monitoring the activities of their kids, limiting, moderating to some degree the way in which they get involved in digital media. Those are smart things to do. To flip the script again, I think probably the emphasis should be not on reducing screen time or digital media involvement, but on increasing non-screen based activities, getting kids enough time away from the screen, physically active, engaging in conversation, in face-to-face social interactions. But all of these things, while they're relatively common sense for us to say, are only loosely supported by the data that we as scientists have been able to collect. We're doing our best. Clinicians are doing their best to address what is a real problem, which is excessive or overuse of these digital media. But it is hard to construct advice based solely on what evidence is available to us.
Yeah, thanks, Jason. Mark, any comments that you'd like to make to that? I've also been scanning the questions, so I have some comments to the questions that come from the audience. But Mark, I want to give you a chance to respond.
Yeah, I do agree with the number of the points about the digital technology environment changing and about how we might think about using both common sense approaches and trying to achieve a greater balance, if you will, between screen media activity and non-screen behaviors. I think, I don't know if we've mentioned it too much during this webinar, but the COVID-19 pandemic has had a big impact on a lot of youth who are at varying developmental stages and with different geographic locations, implementing different approaches, but a large number of youth needing to move from in-person types of behaviors and learning to screen-based learning has been, I think there are individual differences associated with how the children have been responding, but by and large, a number of children have been struggling in this environment. And adding upon that, the stress of living in a pandemic and the fears that are associated with that and the psychological stress. So over the past decade or more, there's been an increasing awareness of, and perhaps worsening too, of children's mental health that I think the pandemic may have only worsened or accelerated that process. And how screen media activity fits into that is complicated. So one study that I didn't mention was a longitudinal study that was initiated prior to the pandemic and then continued into the onset of the pandemic, and looked at relationships between problematic smartphone use and problematic gaming and psychological distress. And prior to the pandemic, so three waves. Prior to the pandemic, problematic gaming was associated with worsened psychological stress at time 2, but it wasn't from time 2 to time 3 during the pandemic. Whereas problematic smartphone use at the beginning of the pandemic was not associated with psychological stress at time 2, but going from time 2 to time 3, it was associated with worsening psychological stress. So it suggests that one possibility is that gaming may have become more, may have had more benefits during the pandemic when it may have allowed youth to socialize, whereas beforehand there were other things that they could do that were more healthy. And when more access about fearful information related to the uncertainties of the pandemic became more readily available on the smartphone, then problematic smartphone use then may have led to more psychological distress. That is largely speculative, but it's one possibility that the data in this longitudinal study in China support.
Yeah. Well, I think what's emerging, and I've been scanning the questions and the comments that came on from the audiences. We have to say, and I just want to go a little bit into when we did some studies with the ABCD data, one of the things was very clear to us is that screen media activity does not happen in isolation, of course. It happens within a certain family environment. It happens differentially within a certain socioeconomic class. It happens with other coexisting activities. And so trying to isolate what is the effect of screen media activity on the brain or on behavior is actually a very difficult task in and of itself. And I think we all kind of mentioned this at some point, and that the effects are on average modest. I mean, to say I want to really emphasize we're not having the data here to say, oh my God, this is Armageddon here in terms of screen media activity. We just don't. But what I think where we're struggling here is trying to identify for whom screen media activity could be problematic. And it gets back to what is innocent or part of a developing world that we're all part of, and what is problematic. And again, when we did this study where we took all of these different factors, family environment, all the socio-demographic factors and some other factors into account, we did find a subgroup of kids for whom increased media activity was associated with problematic associations, like more externalizing, internalizing, those kinds of things. And it seems to be related to sort of brain developmental stages. Like Jason talked about, the cognitive control part, the executive functioning, the frontal part of the brain, and sort of the yin yang between that and the reward-driven part of the brain. And it seems like if there is an imbalance between sort of who's in charge, there could be a problem there could be problematic outcomes. But again, this is very early data, and so it is the case that it's not for it's not uniformly negative, the screen media activity is. It gets back to something else, and there was a question that was raised. What kind of other activities can we engage in to foster cognition? And one of the issues that was brought up was this dyadic reading, reading with your child. And that is a group activity, it's a social activity, it's an interactive activity. And by all means, those are very important. And in fact, one of the things we found in these early and Jason just actually brought up, and Mark brought up too, kids use screen media activity like texting, chatting, things of that nature in terms of social relationships. And when used in that context, it actually is could be beneficial. And we found a small beneficial effect for the kids who are using it that way. But coming back to, and Jason, you'll be coming back to the dyadic reading, I think that this is a social activity. I think it's very much something that we would want to encourage. And it gets back to also building attention span, right? Reading together for extended period of time. Jason.
Yeah, no, I just wanted to touch on something you were just discussing here, which is there is a perhaps misperception that spending more time engaging with others online means the kids are somehow sacrificing face-to-face time. But this actually turns out to be much more complex when we look at it empirically. It does turn out that kids who spend more time not in digitally oriented social interactions actually also spend more time in face-to-face social interactions. In other words, kids who are social, who tend to engage with others, like to engage with others, whether it's through a screen or out in the real world. And so the idea that somehow they're getting lost in these, like only internet-based social environments is probably wrong. And actually, to extend the point one step further, those individuals who might not engage in social interactions out in the world are much more encouraged to do so in the social environments that are behind the screen. And so it's an opportunity for kids who are not getting normative socialization to actually experience it. The outcomes for individuals are very hard to predict, but it's not a simple story. And parents who are worried about their kids always just doing they're in group chats, they're in video games, interacting with others, those might actually be very healthy ways for them to be getting socialization when otherwise they'd be retracted.
No, I think very good point. I'm being reminded that we wanted to bring up one issue, and I'm just going to bring this up very quickly, which is, when we come to multitasking, we talked a little bit about cognition and executive functioning and control and flexibility and things of that nature. And I think that there still is a misconception out there about how the brain does or does not multitasking. The truth of the matter is, what we know from cognitive studies in adults and in children is that when you engage in a cognitive effortful task, reading or listening to something, and you really pay attention to this, you can't multitask. You have the impression of multitasking, say you're reading something and you're reading something else, but what the brain is doing, it's switching between paying attention to one thing and paying attention to the other thing. But here's the issue. The switching itself costs the brain processing power. So what that means is that you think you're doing two things at once, but what you're doing is you're doing two things not so intense and then spending extra brain power and brain cognitive energy switching between those two events. And that is where we come back to like the attention span, right? I mean, so building attention, being focused on one thing for an extended period of time, building deep experiences cannot occur in a multitasking environment. It just cannot. We have to be aware of that. That's not true in adults, and it's not true for children. So one of the things that I would really strongly urge parents to look at is provide the kids with the opportunity to not multitask. Sometimes we do multitask, we're switching around, that's good, that's fine, there's nothing wrong with it, but also give the children time to just be with one thing, paying attention to one thing. That builds depth of experience. And I think, and maybe Jason can say a word about this. This multitasking, it's sort of like these little dopamine juices that we're getting from, let me pay attention to this and let me pay attention to that. And effectively, what you're doing, you're training to your reward system, but you're not really training your cognitive system. Jason, what would you say about that?
Yeah, no, I'd love to respond there. So let me again back up just for a second by saying, there are a lot of, I think, controversial claims about relationships between outcomes in cognition and specific screen media involvement and activities. What is really not controversial for any of us is that when somebody is engaged with their screen device, they are not able to attend to other things going on in their world as well as they would be if they weren't simultaneously trying to be on their screen. We all agree about that. So in the moment, it's taking away your attention from the classroom, from a conversation, from your family, from your friends. We think that's happening. The controversial question is whether that has a lasting negative impact on your capacity for attention, whether somehow it shortens your attention span to be in the habit of multitasking with your digital devices. I think the evidence there are much less clear. And to go back to something that was in Dr. Barron's presentation, she talked about brain plasticity. And for years and years, we've been running studies looking at how the brain changes through experience, through practice. And so a kid trying to defend their digital media habits might say, well, I'm just getting practice at multitasking. I'm getting good at it. That's what it's doing. That's the world that I live in, and I need to get good at that. So I should multitask a lot. And here's what I think we know at this point in time. They're probably wrong. That is, practicing with multitasking, as Dr. Paulus was just explaining, really isn't multitasking. You're just attention switching. It's not very effective. And it is definitely associated with having a weaker capacity for focused, sustained attention. But there is, again, a little bit of an out, something that somebody could perceive as a benefit in certain environments. And that is those individuals who spend a lot of time media multitasking, they actually are more distractible, that's bad, but also better at picking up on things that are going on in their peripheral environment. Because they're less focused, they're actually more aware of something that's happening outside of what they're doing. So it's this peculiar, you can't say it's all bad, it's all good. It really depends on the context. And if I'm going to leave the parents with a message, context matters, right?
Yeah.
It really does matter when and where these kinds of activities are being manifest.
Mark, one question that has come up in the audience, maybe you can speak a little bit to us. We are digitalizing our learning environment. Kids are using laptops, they're using pads, iPads, and things of that nature. What does that do, particularly for those kids who are susceptible, say, to even developing addictive types of behavior in the context of screen media use?
Yeah, so the relationship between using digital devices for learning and how that impacts development, I think, is complex. So one study that comes to mind, one that we were involved in with investigators in China, was to look at encyclopedia-based traditional types of searching versus Google type internet-based searching, and found that the internet, while faster, the internet-based searching was faster, there was less accurate recollection from the internet-based searching versus the encyclopedia-based searching, and there were neural mechanisms that were implicated in that process. Then with schools distributing digital devices for learning, it has the potential to increase the learning of students, making things more efficient, preparing them for a digital environment. While at the same time, there's also the potential for distraction and using the internet in ways that the children are not supposed to be using the internet, searching for online content that could be not only distracting, but also detrimental to development. Online pornography is something that comes to mind, and problems that youth can develop during childhood or adolescence that may impact their development then and into the future, particularly with respect to how sexual arousal templates are developing. So all of that being said, I think, as has been pointed out, these are complex issues, and there's no black or white type of all good, all bad. There are nuances, there are contexts, and one needs to take these into account, including the individual differences in youth and their behavior and how they may be impacted through different life experiences.
Yeah. Well, thank you, Mark, and thank you, Jay. So we're getting to the end of this segment, and so I think that I'm very excited and I'm very grateful to be part of this conversation. I think what's important is that we're going to continue to have these discussions. And what Mark just finished with, understanding the complexities and the individual differences requires ongoing conversations. You can't just say, this is it, and now we know it, and that's it. That's not how it works. But I'll now give the microphone back to Pam for some final words. And again, I want to thank the audience for sticking with us. Hopefully it was exciting to you and somewhat interesting. And Pam will tell us what's coming up.
Thank you, Martin, Mark, Jason, for taking the time to share all of that rich knowledge and insights with us this afternoon. Thanks also to Naomi for sharing some great research and advice, even though she couldn't be with us today. We appreciate all of you at home and work for joining us for the webinar as well. I'm sure there will be some very interesting dinner table conversations this evening. When you leave the webinar, you'll be asked to complete a short survey. Please take a moment to let us know what you thought of the webinar. To continue learning about this topic, be sure to visit our website at www.childrenandscreens.com and read our tips for parents and other resources. Again, be sure to check out how you can win a chance to select your very own webinar topic. For $100, you'll be automatically entered into a raffle to choose our 2022 webinar topics. The funds will be used to support the Institute in providing this excellent webinar series. Learn more on our website. We'll post a video of today's webinar on our YouTube channel, to which we encourage you again to subscribe, and we hope that you'll share resources with your fellow parents, teachers, clinicians, researchers, as well as your friends. For more from Children and Screens, please follow us on Instagram, Facebook, Twitter, LinkedIn, etc. at the account shown on your screen. Join us on Wednesday, November 17th, as we address the recent news around the Facebook files and where to go from here. It should be a fascinating and informative conversation. Thanks again for being here today. Everyone, be safe and well.